Okay, so law of cosines. I want to prove it to you, or kind of go through a geometrical proof, if you will, of kind of why it works. So let's say I got any old triangle here. Okay, not a right triangle. Just any old triangle. The side lengths are A, B, and C. Okay, I'm going to again draw the height there. So I'm going to drop down the height. We'll call it H because we're creative. Okay. All right. And then let's call this length right here X. And if that's X, what expression could I use? I don't want to introduce a new variable. What expression could I use for that length right there?
X.
Nope, because it doesn't cut it in half.
Z.
What?
X plus Y.
Nope, not quite.
X minus.
How long is this whole side?
C minus X.
How long is that part?
C minus X.
So this has to be
C minus X.
C minus X, right?
C. That makes sense.
Okay. All right. Would you agree that A squared equals C minus X squared plus H squared?
Yes. Yes.
Look. Look. What did I use? Pythagorean's theorem on which triangle? The one on the left up there, didn't I?
Oh, okay.
C minus X squared plus H squared equals A squared.
I know.
Everybody sees that?
Yeah.
Okay.
Yeah.
But now that I told you how I got that, you see it, right?
Yeah.
Okay. All right. I'm going to do a little bit of some FOILing, some algebra here. So C minus X times itself, right? I'm going to square C minus X. C squared minus XC minus XC. So that's minus 2XC.
I don't like that one.
And then plus X squared. So all I did was FOIL that out, distribute that out. C times C times X times C, X times X. There's some negatives in there, so that's why it's minus 2XC. I'm going fast, so I'll write this out. For those of you not seeing it yet, those are like terms. Okay?
Okay.
Questions so far? Alright, now keep in mind I'm doing law of cosines here, and I really only want it to have A's, B's, and C's in it, so I really don't want to have the X's and the H's in it, okay? X squared plus H squared. What would that equal?
B.
B squared, why?
Because it's a right triangle and that's Pythagorean's theorem.
Is that a right triangle over there?
Yeah.
What would X squared plus H squared have to equal? B squared. So is it okay if I replace X squared plus H squared with B squared?
Yes.
Yeah.
Okay.
Maybe. Maybe not.
Shut up.
This is what math is awesome, guys.
Oh yeah. Agree to disagree. I agree, math is awesome. Come on, man.
All I'm going to do on this next step is move something around to make it just look a little bit nicer. Okay, I'm going to move the B squared to be the first term. Okay, I'm not doing anything crazy here, guys.
You're welcome.
Okay, I didn't do anything crazy there. I just moved the B squared to the front part of the expression. I got to get rid of that X. It's going to involve that angle A right there. And crazy, it's probably going to involve a cosine since this is law of cosines.
Ooh, okay.
What's the cosine of angle A? Cosine of angle A would equal what? Adjacent over hypotenuse, so x over b. So really x would equal what?
B cosine A.
B times the cosine of A. Multiply both sides by b.
This is way more confusing.
Where am I losing you?
I'm not sure what you just asked actually.
So we just plug everything in, basically.
Hmm?
We just plug, would we plug the x in for 2x?
That's, yep. My goal of doing this was to be able to have something to substitute in for the x down here, because I don't want to have an x in this. I want to have all a's, b's, and c's. So I don't need to split up a triangle and call different variables, but you certainly can. Okay, like I said before, you can almost always split things up into right triangles and get by with it. Okay? But my goal in the law of cosines here is to replace, to get everything in terms of a, b, and c. So now since x is equal to this, I can substitute this in for that x, right?
Yes.
Right? A squared equals b squared plus c squared minus 2. Right now I'm going to substitute it in exactly as it is up there, so I'm not losing anybody. Law of signs you definitely have. It's on this week's test.
Yeah, I don't know how to do law of cosine.
Law of cosines? This could be fun. Now, watch what I'm going to do here. 2 is being multiplied by b, which is being multiplied by the cosine of a, which is being multiplied by c, right? They're all being multiplied together?
Yes.
So does it matter the order I write things when everything's being multiplied? Okay? So I'm going to just scooch this c up just a little bit. Scooch is the technical term. That is your law of cosine. Or one of the three versions.
Fun as the law of signs. No, like I like law of signs. Wait.
You like law of signs but not cosines, huh?
Yeah, I see. I didn't know this law of signs. I like still can do it. I have no clue how to drive that. So she'll do rough time on Friday.
Why is it too?
Yeah, go remind me. We're gonna test on Thursday.
So,
Thursday? You bet we can. We'll do it on class Friday. No, I'm gonna throw one on that.
this, like I said, hey up here, okay, this is one version of the law of cosines, and you might be asked, well, why do I need to have different versions? You really don't. You really can just memorize one, and maybe you adjust what the letters are on your picture, okay? But there are two other versions of the law of cosines. They are equivalent, except you just move them around.
So it just get to identify your hypotenuse and all that jazz.
Certain sides, yep.
Yeah.
Okay. Those are the three versions of the law of cosines. Notice they're essentially the same. Okay. But the reason you have three is because are you always going to be given angle A?
No.
No. Like even on this picture right here, I'm given angle C, right? So if you're going to be, the only place to plug in an angle into the law of cosines is always back here at the end, right? Well, if I don't have angle A, how am I going to use this one up here? So then just adjust. Use this one right here.
So like for one of these.
You have to memorize one of them. Once you know one of them, the other two are essentially the same. Okay? Well, they are, because it's like, if A is here, angle A is at the back end. So if this is B, then angle B is at the back. If this is C, angle C is at the back. And then the other variables are just mixed into those other two spots. Okay?
I like it. Let's do this.
This law of cosines will be helpful when you are given side angle side. So if you're ever given side angle side in a triangle, you'll want to use your law of cosines.
I like it.
Okay? I won't get to one of these probably for time purposes, but if you're ever given all three sides of a triangle and you need to figure out the missing angles, you will have to start with law of cosines in order to do it, because law of sines is not helpful enough. Okay?
Sounds good.
So let's do this problem here then real quick. Come back here. Let's set it up. Who thinks they want to give it a shot?
Lainey does.
Be brave.
Lainey does.
No?
I don't.
Come on. Becca, you got it. Here we go.
Oh, I thought I had to walk up there.
Yep.
I could do this.
13.
Yep.
Would be.
So,
7.
how am I going to write this?
Oh, we're doing the bottom of C squared.
Do we want to, is this what we want to solve for first?
Yeah,
Little
C.
c?
Yeah, sure.
Okay. So c squared equals.
13 squared.
13 squared.
So 13 squared,
Plus
17 squared.
17 squared,
Minus 2 times, I don't know what it was. 13. And then times 17. And then times cosine of c.
which would be 63 degrees, right?
Then you do that.
Actually, I'm going to change this. I'm going to put my parentheses all the way in front.
Okay.
Okay? So, c squared equals a squared plus b squared minus 2 times a times b times cosine of angle c.
That's a lot of work.
Okay? Takes 2 seconds. Type it in. Okay, maybe 10. You guys are really fast at texting. I know you can get good with calculators too.
Maybe. There's a lot of buttons on there.
We're
Pretty sure I don't have squared.
Is this the answer?
JP's got this.
I can't see that, JP.
What kind of answer?
I got 257.33.
Seems a little bit insane.
34 if you want to round the 6.
That's what we
I
got.
find that hard to believe. I know that's not the answer because two sides of a triangle must always
And you
have
have to
a
square it.
outside. What did he forget to do?
Square it.
Square root.
Is it just the answer or is it a certain part of
So
it?
c squared you said was 200 some?
Yeah.
Okay. So then c
It's 16.
is about
Yeah, 16.0.
16.0.
Just 16.
That was
Wait.
stupid.
Okay.
So I got this.
You can quit taking off.
Not doing that.
I don't have a square root.
Now we can do
This?
You gotta follow directions, don't you, Meg? Yeah.
Yes, we can use sign. Let's start using
Oh, right
sign.
right.
How are we doing on this?
Good.
Muy bien.
Okay. Once you get this side, can you use law of sines to finish it?
Yes.
Yes. Now, JP, will you do me a favor?
Yeah.
And I guess it's still in. Would you read off all those decimal points for me?
Decimal
For
points.
C?
16.04170188.
Okay.
There were 2 8s. Oh yeah, that's a good thing.
Alright. As you go forward and you use law of sines to finish this problem, I would ask that you use this. Okay? You shouldn't have to type that in every time. Okay? There's a great function called previous answer. It's on your negative sign. Okay?
Yeah.
What's that?
I like knowing that. I didn't know that until right now. I
Yep.
didn't know that either.
So that way you don't, if this is your most recent answer on your calculator, and you haven't deleted it, okay? Or maybe it's even still there. Yeah, it is. Okay, previous answer, it's still there. So then, if you set up your law of sines, and you go this 16 number over the sine of 63 equals 17. I'm going backwards here now, aren't I?
Yeah, I thought
Okay.
so, but I was not sure.
Doesn't matter. Does it matter if I do this way or I put the angles on top, guys?
No.
It doesn't.
Doesn't matter if we use that of 8.
4 over 3 equals 8 over 6. Those are equal. If I did 3 over 4 equals 6 over 8, that's equal too, right?
Yep. Yes,
Okay.
it is.
So, but I'm messing with you now, so I'll change that.
Is it okay if we use sign of 8 then? I'm not typing this all.
Really?
You did it, Lane.
So I can set up my law of sines. Hey, real quick. I can set up my law of sines. Now, I don't know if you guys have done any of these yet. I'm going to have to take 17 times the sine of 63 divided by that previous answer. And that's what the sine of b will equal. So then what do you have to do to that to figure out what angle b would equal? Not divide it.
Oh,
Inverse.
Inverse sine it.
Oh, I love inverses. It's so much easier.
Inverse sine that answer.
Inverse it.
Okay?
They want your social security.
Alright, so that's it. Pause the video for me, please.